Students, today in this class I am going to start exercise 14.1 of symmetry chapter, in which we are going to do some questions based on symmetry. And here we have the first question, which is based on rotational symmetry. See, it is asking which of the following figures have rotational symmetry of order more than 1. Not only 1, they require the order more than 1. How to do this? To understand this rotational symmetry which order more than 1, mark a dot on any of the point. Okay, here I marked here, here I marked here, here I marked here, here I marked here, and here and here. Then afterward rotate your figure. Okay, and see how many rotation the figure looks same or identical. Let's see the first part. In the first part you can see that the point at the beginning is here. Okay, in the second part the point is here, the third part the point is here, and the fourth rotation the point is here. In the first rotation, when I rotate it to clockwise, the point goes here. Then again if I turn the second times or rotate second time, it goes here. Third times it goes here, and fourth time it goes here. And every time it looks similar. Why it is similar? I am not talking about only the circle here. Also I am talking about the lines between them. Okay, clear? I'm also talking about this. So this line should be in the same format. So this is first, second, third, and this one is fourth. Fourth time this figure looks same, so it have a rotation symmetry of order 4. Next, whereas if we talk about the triangle, I made a dot where? Here. After one rotation it goes here, and after second rotation it goes here, and third rotation it looks again there. Okay, so at the 3 times in all the figures it looks same. If we not consider the point, the imaginary point which we have drawn, then all 3 parts are look same, unless if you hold in any other way it not look same. So it contains the order of 3. The figure has its rotational symmetry as 3. Okay, now the C part. In C part we can see that if you are going to rotate this figure first time, so it will look like this. Okay, secondly it looks like this, but it is not similar. Why? Because here the boxes are at right hand side, but in that case the boxes are left hand side. So in the third rotation the boxes goes up, and fourth rotation, that means the complete 360 degree, again it goes here. So it have a order of 1. So we are not considering as the order rotation symmetry more than 1. Okay, so the given figure has its rotational symmetry as 1. Now the next part, the given figure has its rotational symmetry as 2. Why? See the considered part. The figure is this. Okay, H. You can construct a point here. Okay, or you can say here. When you rotate at the 90 degree, it will goes here. At 180 degree, it looks again same like the previous one. Yes or no? Then again it looks like this. So it contains the order of 2 because it is rotating. It looks similar at 180 degree. Okay, also you can do by calculation 360 upon 180. You will get here 2. Now the fifth figure, The given figure has its rotational symmetry as 3. It is similar to the B part. Okay, so you can see that it is also a triangle. If you're going to construct it, it also construct a triangle. So in triangles we have seen above, they form rotational symmetry of 3. Understood? Now the fourth part, it also having the symmetry of 4. So after solving all the parts, what we conclude, A, B, D and E and also F having the rotational symmetry order more than 1. Whereas if we talk about the C, it contains the rotational symmetry order 1. Now question number 2. Give the order of rotational symmetry for each of the following. We need to give the order. So we can consider here, after how many rotation it looks similar. So here we can see that if we rotate it at 180 degree, what is the meaning of 180 degree? See, meaning of 180 degree is this. Suppose this is an arrow. If I am going to rotate this up to here, this will become 180 degree. Understand? A complete half semicircle. A complete half semicircle is 180 degree. If this half semicircle goes a complete circle, again half, next half will become complete circle. Okay, suppose I'm starting from here. So from here to here, it is a 180 degree. Understand? You can imagine a clock from 12 to 6, it forms an angle of 180 degree, or from 3 to 9 it forms an angle of 180 degree. Okay, so the first question have an order of 180 degree. Next, the given figure has its rotational symmetry as order as 2. So in the second one, it having the order as 2. Why? So look at the first part. I told you 360 degree is the answer. It's the complete degree, and if you divide it with 180 degree, what you will get here? 2. That's why you get here 2. Now if we talk about this, at how many rotation you will get a completely exact this figure. So the angle formed here 80 degree. What is it? 80 degree. So what is the measure of next angle? 100 degree. Okay, so this one is 80 and this one is 100. So if you rotate it with 90 degree, so what you will get? This side you will get 100 and this side you will get 80. And the next time when you again rotate it, so this type you will get here 100 and here 80 degree. Okay, now you can see that after second rotation, that means at the rotation of 180 degree, it looks similar. This one is 80, at top one is 80 and bottom one is also here 80. Okay, you can also do the vertically opposite angle. Now as like above, here what we are going to do, divide 360 and 180. What you will get here? 0 0 cancel, 18 to the 36. Rotational symmetry as order of 2. Now the next part, in C, you can see that at how many rotation you will get here? 360 degree. A complete 3 rotation it takes. Okay, 3 rotations means 360 divided by 3. So the angle of each rotation will be equals to 120 degree. Yes or no? So here at 120 degree angle, it forms exact figure as like the original. So 360 upon 120, you will get here 3. Order is 3. Here order is 2, 1, here order is 2. You can see that 1, 2, 1, 2, and the next one the order is 3. Now the fourth one, at the 90-degree rotation, okay, they get exact the same figure 1, 2, 3, 4. Do you see any difference in all 4? No. So actually it is rotating at 90-degree angle. So 360 degree upon 90 is equals to what? 4. Also you can observe with the help of this figure. Here we have 4 figures. 4 times if observe same time. That's why the answer is 4. Okay. So I told you how to find this answer. Either you can do by observation. Observation means count how many times it looks same, or by calculation divide the number of angles of rotation with the total angle. That means 360 upon angle of rotation. Okay. Now E part. In E part it is also 4 times. Why? Because it is rotating at 90-degree angle. Now F part, here we have a regular pentagon. What is this? This is a regular pentagon. 1, 2, 3, 4, 5. 5 sides are there. So this is regular pentagon. And regular pentagon looks similar at 5 times. Okay. So angle formed here is 72 degree. How you will get here? Divide 360 with 5. 5 7 are 35. And 5 2s are 10. Okay. So you will get here each angle is 72 degree. And what is the order of rotation? 5. So you can easily understand, if a square is also a regular figure, square contains 4 sides, so order of rotation will be 4. Equilateral triangle is also a regular figure, and equilateral triangle contains 3 sides, so the order of rotation is also 3. Same as regular pentagon. Regular hexagon also the same. Regular hexagon contains 6 sides, so the order of rotation will be equals to 6. Okay. So in all the regular figures you can do this question directly. Now G part, this is a star, okay, which all lengths are equal. So it contains how many parts? 1, 2, 3, 4, 5, 6. 6 parts are there. So it looks same 6 times. So the answer is 6. Now see H part. Here we can see that 1, 2, 3. This contains 3 legs. 1, 2, 3. So the order will be equals to 3. Okay. And you can also rotate the copy or rotate your phone to observe either it is a rotational symmetry of 3 times or not. Okay. Now next exercise I'm going to start. Name 2 figures that have both line symmetry and rotational symmetry. So you can take any regular polygon. Here I have taken regular triangle, that means equilateral triangle, and regular hexagon. You can write square, regular pentagon, etc. Okay. What you can write? Square. Now question number 2. Draw whether possible a rough sketch of a triangle with both lines and rotational symmetry of order more than 1. Second, a triangle with only line symmetry and no rotational symmetry of order more than 1. Third, a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. And fourth, a quadrilateral with line symmetry but not a rotational symmetry of order more than 1. See the first question. What they are asking? A triangle with both line symmetry and rotational symmetry order more than 1. So there we have only one triangle, which is equilateral triangle. Okay, so you can draw a rough sketch of equilateral triangle like this. if you draw a triangle and afterward if you will draw these marks, so it shows that these two lines are equal, and if you draw another mark, so it shows that all three sides are equal. Okay, so this is a rough sketch of equilateral triangle. Also, after writing it, you write here which triangle it is. Equilateral triangle. Okay, now next, a triangle with only line symmetry and no rotational symmetry of order more than one. A triangle with only line symmetry. There is a triangle which can have only line symmetry but no rotational symmetry. This is isosceles triangle. Okay, see how you have to draw. This is the answer of first one, and afterward you have to show like this. And second is isosceles triangle. Third question is a quadrilateral with a rotational symmetry of order more than one but no line symmetry, that is parallelogram. Parallelogram have the order of rotation 2. Okay, at 180 degree it looks similar. You can see here in the first case the dot is here. When you rotate it 180 degree, so the dot will come here, but in both the condition they both look similar. Now in fourth, a quadrilateral with line symmetry but no rotational symmetry, that is kite. Okay, now the next question, if a figure has two or more lines of symmetry, should it have a rotational symmetry of ortho more than one? Yes, if a figure have more than two or more lines of symmetry, then it will definitely have its rotational symmetry. Now question number 4, filling the blanks. Here first you make all these figure square and write the order of rotation, then angle of rotation. Rectangle, so square, draw this. This is not a square, this is a rectangle. Wait a minute. Okay, first we saw draw a square, then mark angle of rotation. The angle of rotation is center of the square. Okay, meeting point of diagonal is the center of rotation, and order of rotation is 4 and angle of rotation is 90 degree. Like this you have to write. So see, in square I told you intersection point of diagonals is the center of rotation, order contains 4 and angles is 90 degree. So what about the rectangle? What is center of rotation? Center of rotation again the intersection of the diagonal, and order of rotation is 2 and angle of rotation is 180 degree. Whereas if we talk about the rhombus, the center of rotation is again intersection of the diagonals. Okay, what does it mean intersection of diagonals? One more time I'm going to tell you about it. Suppose this is a square and the intersection of diagonal is means this. Okay, the common point where the two diagonals are intersecting each other. Now equilateral triangle, intersection point of medians. In case of equilateral triangle do not contain any kind of diagonals, so here you have to draw medians. Now regular hexagon, again intersection points of diagonals. What about the circle? Circle have the center. You know what is the center of circle? If you are drawing a circle, so first thing where you place your pointer, that is the center of circle. So order of rotation is infinite. Why? Because extremely you can rotate. Okay, you will get number of points, so that's why we can write here infinite. And angle of rotation is any angle in any part of the circle. If you rotate at 1 degree, it looks similar, so you can mark here any angle. Semicircle, again the center of rotation is center of the circle, and the order of rotation is 1. it looks one time similar, otherwise remaining time it will not look similar, and the angle of rotation is 360 degree. Okay, so if you know the angle of rotation, then you can easily count the order. I told you 360 degree is the complete angle. If you know the angle of rotation, suppose the angle of rotation is 90 degree, by this you can calculate order of rotation. 9 4 is 36. Okay, or if you have order of rotation and you need to calculate angle of rotation, again you can do the same thing. You divide it and you will get the answer, which is angle of rotation. Okay, 180 degree. So this question was also completed. Now question number 5. Name the quadrilateral which have both lines and rotation symmetry of order more than one. So such quadrilaterals are square, rectangle, rhombus. They are the quadrilaterals which have both line symmetry and rotation symmetry of order more than one. If we talk about the square, here in above you have seen a square has 4 lines of symmetry, a rectangle has 2 lines of symmetry, and rhombus have 2 lines of symmetry. Okay, see here we have a square, rectangle and rhombus. They are 3 quadrilaterals. Now question number 6. After rotating by 60 degree about a center, a figure looks exactly the same as its original position. At what other angle will happens for the figure? So write the table of 60 degree. That means 6, 6 to the 12, 6 3 the 18, 6 4 the 24, 6 5 the 30, and last is 6 6 the 36. Now put 0. These are the other angles in which figure looks similar to each other. Okay. Question number 7. Can we have a rotational symmetry of order more than one whose angle of rotation is 45 degree? Now here you need to calculate order of rotation. Okay, so if the order of rotation is a whole number, then it is possible, yes, otherwise it is not possible. So how you can calculate? 360 you have and divide it with 45 degree. If you get the answer in whole number, that means true, otherwise no. So how we can calculate? Find in the 45, 5 5 the 5 7 the 35, and 5 2 the 10, 9 8 the 72. So here you will get the answer in whole number, which is 8. So answer is yes, 8. Order is 8. Now whereas if we talk about 17 degree, 360 upon 17, 17 to the 34. Okay, now you will have remainder 2, 20, again 17 to 17. Now it is not completely divisible, your answer will be in decimals, so second is not possible. See, it can be observed that if the angle of rotation of figure is a factor of 360, then it will have a rotation symmetry of order more than 1. It can be checked that the 45 is a factor of 360 but 17 is not. Therefore the figure its angle of rotation 45 degree will its rotation symmetry of order more than 1. However, the figure having its angle of rotation as 17 degree will not be having its rotation symmetry order more than 1. Okay, so here your chapter is completed. You write this chapter in your copy, and in next class I will start the next chapter, which is chapter number 15, which is based on visualizing solid shapes. That's all for the today. Thank you and have a wonderful day.